This is question number 3 from revision test for statistics number 1, or revision quiz. So we're told that suppose that x is a random variable, is a variable with a normal distribution, mean 1 and variance 1, then and t is equal to exp of x, then find the probability that t is greater than 14. Well, as soon as you see something like this, you need to start recognizing that this is going to be a log normal distribution. Why is that? Because if t is equal to exp x, then ln t, if we take natural logs of both sides, is going to be equal to x, and we know that x is a normal distribution, so log t, or natural log t, is a normal distribution. So normal distribution, which is equal to normal mean of 1, variance of 1. So all we have to do now is, now that we know that ln t is normal, we need to find the critical values for this part here. So for t is greater than 14, what are we trying to find? The probability. So we're trying to find a p-value, a one-sided p-value that t is going to be greater than 14. This is not to be confused with a little t from our t distribution. So don't do that. Don't do that. Let's wipe that out so it's not confusing. Okay, so what do we need? If t is equal to 14, well, what do we want? We want to find we want to use our normal distribution here to find this probability. So we want a z statistic. And what's our z statistic going to be? It's going to be equal to, well, let's see, we've got a normal of 1, we've got a mean of 1. Let's just write what this is going to be. We got x bar minus mu, so that's the mean, over our standard deviation, because we've got a normal, we've got a normal distribution, and this is the standard deviation on the bottom, which is square root of 1, which is 1. So what's our x bar? Well, instead of putting in t is equal to 14, we just need to put ln of 14, because that is the variable that is normally distributed, minus the mean, which is 1. It's all divided by 1, so we don't have to worry. So it's just ln 14 minus 1. Let's see what that is. Ln 14 equals minus 1 equals 1.64 will do. And now all we have to do is go to our table of z values and find 1.64. 1.64 is going to be, so it's page number 515 in the statistics tables. 1.64 is going to be 0. So the probability that z is greater than 1.64, or actually this is the probability that z is less than 1.64, is what's given to us in the table, is going to be 9495. Is that the answer? No, it's not. We want the probability that it's going to be greater than that. So we need, so the probability that z is going to be greater than 1.64, and that's going to be equal to 1 minus 0.9495, which is equal to 0.05 to 2 decimal places, or 0.0505 or whatever it is. And that's our answer.